Yeah, all right. So let me start the last session of today. And my name is Denis Shestakov. I work as a Hadoop engineer at a company called Bright Computing. So our specialization is cluster management. So we are a software development company specializing on cluster management solutions. And that's why is my talk. So I'm going to concentrate for next 30 minutes on Hadoop clusters. The motto of our company is to make cluster management really easy. So in this sense, I would like to start with this slide to formulate, to a bit elaborate what it may mean for Hadoop cluster management. So first of all, we'd like to have fast deployments of Hadoop clusters, and by fast deployments, I mean the installation of Hadoop cluster on bare metal server till a running Hadoop cluster. Then our next goal or our vision is to make maintenance and management of your cluster as easy as possible. And I'm going to elaborate maybe in a couple of minutes, but sorry? Yeah, all right. So one of the issues currently, as most of you heard, is that there is a lack of people with Hadoop skills. And one way to think about it is that, in fact, while indeed is the case, there are quite many very experienced cluster or network administrators, and it would be great to actually reuse their skills. And another high-level goal is to build cost-efficient clusters. So nowadays, when Hadoop passed this teenage age, when people actually realized what Hadoop can deliver for them. So I think now what most organizations concern is how to get most of their Hadoop cluster. And having this in mind, so let me give you an outline for my talk. So first of all, I will just give you an overview of Hadoop cluster operations. And again, I will be talking about installing and deploying Hadoop on bare metal servers. Then I'll talk about Hadoop deployment and maintenance, and I will try to explain what kind of problems there exist. After that, I'll proceed with overview of architecture. So our approach, how we try to overcome existing problems. So essentially, it's a presentation of our architecture solution to simplify Hadoop cluster management. And then after the architecture will be explained, I will talk about actual implementation of this architecture, which is Bright Cluster Manager for Apache Hadoop. Then it will be very brief, just a couple of slides. It will be open issues and conclusion. Okay, so let me just give you some idea about the Hadoop cluster operations. meaning that we deploy Hadoop on bare metal service. Well, firstly, of course, a person or team who's involved in Hadoop cluster building, they need to consider these issues such as which hardware to choose, network design, how to build the network, so it should take into account the size of your cluster, also the data growth, expected data growth, etc. So there are actually, for instance, at the previous Hadoop Summit in Europe, there were a couple of talks addressing these issues, but it's out of the scope for this talk. And then the next actual operation is deployment, meaning that so it concerns the network setup, also all the servers in your cluster should be so the for all the nodes in the cluster, there should be disk partitioning and disk setup done. And also provisioning. The next operation is provisioning, which is actually delivering software, a particular software image, or a different set of software images to nodes. Well, essentially, provisioning is a part of deployment, but for cluster operations is really critical. That's why so I make it as a separate dedicated operation. Then the next issue is to actually to do selection of Hadoop distribution and version, which is depending on a person or team who's doing this Hadoop deployment. It's not really trivial. After this, when distribution and version is selected, the next thing to do is configuration. Actually, it's quite complicated process in itself, and it represents a challenge even for very experienced Hadoop guru, so to say. Then after cluster is deployed, we proceed to actually maintenance of this cluster, which involves basically all sorts of operations, commissioning, decommissioning nodes, starting, stopping, restarting services on Hadoop level, and on a operating system level, it would involve software upgrades, library upgrades, etc. Then this is very essential operation, and I can clearly say it right now because we actually talked in the exhibition area with quite a number of people. So they're particularly asking about the monitoring. How do you monitor your cluster or Hadoop instances running on your cluster? And related to monitoring is health checking. So the, for example, depending on how your cluster actually operating, it's so you can set host alerts that, for instance, can give you notice in case potential trouble might appear. And finally, optimization. So actually, again, according to our experience so far, at least with many Hadoop clusters, actually people who operate in them, they don't really reach this optimization part. But it's tightly related actually to monitoring and health checking. Then basically, so let me have all these operations again. And here, what I want to show is that actually these operations, they involve management your Hadoop cluster as well as your operating system or network parameters. So essentially, only in two pre-Hadoop installation steps, so deployment and provisioning, it's only at these steps when sorry, I lost the point, but the idea is that for monitoring operation, ideally you monitor not only your Hadoop components or Hadoop services, but also operating system details, memory usage, Java heap memory usage, some network parameters, etc. Okay, and now let me talk about Hadoop deployment and maintenance, and specifically what actually the problems currently exist. So it goes without saying, but without proper infrastructure setup, Hadoop will not run. It's actually lots of Hadoop applications or Hadoop analytics guys, they forget about it. So actually, your Hadoop instance is running on a actual bare metal servers, and they have to be managed and taken care of. And proper Hadoop configuration, I'm not even talking about the optimization and tuning step. It actually involves heavy configuration of network and operating system parameters. So it's not only configuring your Hadoop services. And perhaps the real problem, the real issue is that expertise in cluster administration and Hadoop administration, they two together, they are relatively rare. Let me elaborate on this issue. So if we consider Hadoop cluster from the perspective of, let's say, a Linux cluster administrator, then perhaps the real challenge for him or her is that the real challenge is lies in configuring Hadoop components, and specifically, actually, the proper configuration is really hard to achieve without more or less good understanding how MapReduce works or HDFS file system operates. And Linux administrator guys often miss this knowledge. Then this is big problem for the Hadoop space, is that there are too many configuration settings for Hadoop optimization. And moreover, the proper configuration very often involves actually finding out certain subsets of these configuration settings. that might work for your particular environment. Then another problem which appears maybe from some lack of knowledge about the Hadoop is how to choose Hadoop distribution. So this might be a real issue. And then another problem, it's about different Hadoop modes. Here what I mean is that if we consider only HDFS, you might install it in several modes. For example, in high availability mode or regular mode. And again, so what's the difference? How to actually set a particular Hadoop mode? This is a real challenge. Then, from the perspective of Hadoop administrator, there are also challenges. And Hadoop administrators, it might be people who would build their not that big Hadoop clusters as Hadoop developers. So they often, for example, did some development, and because of their success of their test and development Hadoop clusters, actually they moved to production phase. And with such people, they really know Hadoop very well, but still there are challenges. Of course, configuration is still hard. Again, it's numerous configuration parameters, so this is a real problem. More specifically, if I would be even more specific about these parameters, for instance, there are so-called deprecated configuration parameters. So certain parameters are not used in Hadoop versions 2.0 and higher. Then issues with migration from Hadoop 1 to Yarn also might be a problem. Then, assuming the Hadoop cluster is deployed, so typically you need to ensure that indeed it was deployed and built correctly. So typically it involves running several test and benchmarking jobs just to be sure that all services are up and the actual Hadoop job can be completed. Then on your running Hadoop cluster, you do extensive monitoring and health alerting. And of course, you do care about upgrades, so about new releases, so kernel updates, etc. In practice, most of people who do Hadoop cluster management, they basically use at least 4 different sets of tools. So first of all, they have a set of, let's say, tool for provisioning, for delivering software images to the nodes, to their cluster. Then for configuration of their Hadoop as well as actual cluster nodes, they use different configuration facilitators such as Chef or Puppet or just Perl or Python scripts. Then for monitoring, the typical example of tools that people use might be Ganglia or Nagios. And of course, nowadays, most Hadoop cluster administrators, they use some Hadoop cluster manager. So for Hortonworks, we all know it's Apache Ambari, or, for example, Cloudera Manager for Cloudera's Hadoop. So obviously, and as a goal, as a vision, it would be great to get rid of these tools or try to combine them in just one tool. And that's why we came up and proposed with the following architecture for Hadoop cluster management. So first of all, I would like to give you several considerations that should be taken into account in this architecture. First of all, in real IT environments, it's very often that there are several Hadoop clusters running for production, as well as for development and pilot purposes. And of course, requirements to these clusters, they are obviously very different. For example, of course, for pilot or development Hadoop clusters, the ability to choose from a particular Hadoop distribution is really appealing. Then, when we consider nodes in our Hadoop cluster, actually we can classify them into several groups. It will be the master nodes, worker nodes, and gateway nodes. Master nodes, essentially, it's those who run the central Hadoop services, such as name node or resource manager or job tracker. Worker, these are the main working nodes that actually they store the data and run Hadoop jobs. For worker nodes, it's typical that they share similar operating system and software stack. And if we consider cluster as a whole, we should expect that it's going to grow. So more nodes is going to be added. So these batches of growth might be from 2, 3 nodes to perhaps 10 or 15, depending on the how big your organization. Then we should also take care of node replacement. So ideally, the node replacing should be as painful as possible. I'm sorry. Vice versa. Yeah. Okay, and then another problem in typical Hadoop clusters is that it consists of nodes with heterogeneous hardware. So I mean that a subset of nodes might have different amount of memory space or number of cores, etc. So ideally, it should be also taken into account. And it might be taken into account by providing this grouping ability to the architecture. So here is the architectural sketch. So the idea is that each node in a cluster will run a special agent or daemon. We just call it cluster management daemon. And we prefer this central architecture with a head node. Of course, the single point of failure for head node can be taken into account by providing failover head node. And then, of course, there should be actually interface provided to this cluster management daemon. For cluster management daemon, the requirements, the ideal requirements is that it should have low overhead. Then we consider that it would be simpler if all nodes would run the same daemon, the same agent, but based on the roles defined for a particular node. Actually, this node, I'm sorry, the roles assigned to a node would actually define the type, the type and things that actually this node can perform. And just more information about this role approach. So, so according to our architecture, a role can be assigned to a node. And assigning a role to a node means that this node can perform a certain task. For example, if it would be provisioning role, then having this role assigned, making this node to push software images to other nodes. Or if it would be Hadoop specific roles, such as name node role, for instance, then basically this makes a node with HDFS name node role to store HDFS metadata and also control the nodes with data node role. Okay, now with this architecture in mind, let me talk about our implementation of this architecture in a tool which is called Bright Cluster Manager for Apache Hadoop. So it's just more elaborated architecture picture. So it resembles the presented architecture. So head node can accept only SSL connections. So all communications in a cluster is secure. We use JSON calls, and JSON is used as a transport layer. And a cluster management daemon, or we call it SIEM daemon, it can be accessed via several means: command line interface, graphical user interface. Also, we provide Python API and web interface too. So perhaps more details about the graphical user interface is actually, it gives a person who runs the cluster a full control. So from SIEM GUI, it's just one panel, one dashboard from which a user can control both Hadoop stack and the underlying physical nodes. It's possible to also manage several clusters. Then another interface is command line interface. Basically, it gives you all the functionality of the GUI, and on top of this, certain actions can be scripted and then executed. So here's the overview of our graphical user interface. So on the left, you can see all the resources in a cluster, and I think it's not really, perhaps it's hard to see, but basically the Hadoop cluster is just one of the resources in a cluster. It's somewhere in the middle on the left. And the right panel, it gives you, depending on which cluster resource is selected, it gives you an overview for this resource. And also, as you can see, you can see some metric selected about this resource. we our tool can manage different types of clusters. It's high performance HPC clusters, high performance computing clusters. So this is was the initial task for Bright Cluster Manager, and now in our most recent release, we can manage also OpenStack clusters, Hadoop clusters, and for clusters of any type, a user can deploy, configure, provision, manage, monitor, and do health rating of specifically about Hadoop cluster. All these operations can be done also on software image level. Then in terms of Hadoop support, we provide a choice of distributions. We support all major Hadoop distributions: Apache Hadoop, Hortonworks, Cloudera. We provide you with a dashboard, like you just see, from which you can manage and monitor your the whole cluster from just one place. Then we serve the interfaces depending on your preference: command line interface or graphical user. It's not only that we provide Hadoop support, so nowadays Spark got momentum. So since the most recent version, it's possible to actually just install Spark in standalone mode and having no Hadoop. And we care about flexible configuration. So current release, so it will be in 2 slides where I will talk about the configurations. But this is the overview, so the windows that a Hadoop administrator can see. So for each Hadoop component, let's say in this example it's HDFS, you can see the general overview of it on top, and also perform certain operations. So the similar windows exist for Yarn, Zookeeper, HBase, and Spark. Then SIEM-Daemon is supplied with extensive monitoring abilities, and the great feature here is that you can combine metrics, like in this window. So it might be Hadoop metrics and also like operating system level metrics, such as memory or CPU usage, etc. So all in one place. And the monitoring capabilities are really advanced. So we serve a really huge number of metrics, Hadoop and operating system or network level metrics. And we are dedicated windows. Actually, you can see them all and also combine like this. You can aggregate them on a node level, or you can do node grouping and show them together. So monitoring functionality is very advanced. Then some information about configuring Hadoop configuration. So we do this configuration via roles. And in the current release, we have 15 Hadoop roles and 3 Spark roles. So the example of roles you can see. And it works in the following way: that if you assign a role, then it would write corresponding configuration files to corresponding nodes, and then start or stop if you unassign a role, corresponding service. So here is the example of our configuration capability. It's called Hadoop configuration groups, and the idea is that now you can group your nodes into, so you can form sets of nodes and then define different combination of roles for these nodes, and also different combination of configurations. So overall, so the version 7.1 of our Bright Cluster Manager for Apache Hadoop is just released. It gives you just one interface to manage both physical and your Hadoop cluster. It gives you fast and easy installation of Hadoop. In terms of supporting, in terms of supported Hadoop distributions, so here you can see more details. So it's all major ones. We provide configuration monitoring and health alerting abilities of Hadoop instance, as well as your physical cluster. Within one cluster, you can create several Hadoop clusters. And of course, it might be different Hadoop distributions and versions. Advanced configuration abilities. So our new feature, Hadoop configuration groups, addresses the problem of heterogeneity. It's possible to actually use Python to manage your cluster, since we serve Python API. And a very interesting feature for high performance for HPC guys is that we can run Hadoop not on HDFS as typical, but also on Lustre. So this is HPC widely used file system in HPC world. Okay, so let me perhaps skip open issues and give you some conclusion. So, I just gave you some idea about this architecture for distribution-independent Hadoop Cluster Manager, and the Bright Cluster Manager for Apache Hadoop actually implements this architecture. Again, it's just single dashboard from which you manage your Hadoop cluster and physical cluster. So please visit our booth. We're presenting our new release at the booth S4. So please come. So meet with our team, see the demo, and of course, tell us about your cluster, what kind of problems you have. Do you think this architecture is suitable, its advantages or disadvantages in your opinion? So this would be great. So please visit us. And well, finally, so this is our team just a couple of days ago. All technical and support guys in Amsterdam. So the credits, they all go to them. Okay, well, thank you very much.
So when you say you integrate, you are agnostic on the distribution, yes. Does that mean that you integrate the Cloudera Manager or Ambari into your, or you replace it completely?
Yeah, so the answer is no. So we don't use different. So we use just our Hadoop Cluster Manager. So, so if it's, for example, Hortonworks distribution, then there is no Apache Ambari used. So.
But you could install it if you needed to. I mean, you could have all either, right?
Actually,
Don't think so. It would be hard.
it's complicated because well, there are several modes for our tool, and this Bright Cluster Manager for Apache Hadoop, as it's called, is just actually is basically our main Bright Cluster Manager tool with Hadoop add-on. And this Hadoop add-on essentially gives you this Hadoop cluster management abilities. But so due to current architecture, we can't really use Apache Ambari. So this is due to the fact that our cluster management agent, which runs on all nodes, it takes full control of the nodes. That's why we can't really allow to Apache Ambari agent. I'm not very sure how they're called, but they also